worries. Good afternoon, everyone. Thank you, Abel, for inviting me. I'm Luca Piermarini, co-founder of Blockchain Student Association Italy, and I'm currently studying for a master in FinTech, Finance and Digital Innovation at Politecnico di Milano. It's a real pleasure to be part of this year's Construction Blockchain Conference and to contribute to the discussion on digital trust and traceable systems. Today, I'd like to share some reflections that come from a panel on smart contract security that I recently moderated on a conference in London. And rather than going into deep technicalities, my goal is to offer a broader view to help us understand why smart contract security matters, how it connects with the concept of digital trust, and what we can learn from the way risks are evolving in this space. Let's start with the basics. Smart contracts are often described as self-executing agreements where the terms are written directly into code and deployed on a blockchain. They are the backbone of decentralized applications, so from the DeFi protocols and tokenized assets to automated supply chain systems. The promise is clear: efficiency, transparency, and trust without intermediaries. Very simple. But there is also a paradox, because we call them trustless systems. Yet they require enormous trust, not in people, but in code, in cryptography, and in the infrastructure that supports them. And as history has shown, code is rarely perfect. Over the past few years, vulnerabilities in smart contracts have led to billions of dollars in losses, sometimes because of simple coding mistakes, other times due to sophisticated attacks that exploited design flaws or overlooked assumptions. One of the most famous incidents, the DAO hack in 2016, showed how a single line of code could drain millions of dollars, not because the blockchain failed, but because the contract worked exactly as written. It forced the community to deal with an uncomfortable truth. In decentralized systems, code is law, until the law itself contains a flaw. So the question isn't whether smart contracts are secure. It's what does security mean in a decentralized world, and how can we build trust in systems designed to eliminate it? In traditional software, vulnerabilities can often be fixed with updates or patches. In blockchain systems, once a smart contract is deployed, it's immutable. That immutability, which is a strength for transparency, becomes a weakness for security. And as the ecosystem grows, so does the attack surface. Today, we are seeing new types of risks, especially from AI-driven exploits and cross-chain vulnerabilities. AI can now analyze blockchain data at scale, identifying patterns and weak points faster than any human auditor could. Cross-chain bridges, which allow assets and data to move between different blockchains, have become another major target. They combine multiple security models, and in doing so, multiply the potential for failure. In short, the more connected our decentralized world becomes, the more interdependent and so vulnerable it gets. These challenges require not only technical solutions, but a cultural shift. We need to move from reactive defense to proactive risk anticipation. Looking further ahead, there's another frontier that could fundamentally reshape digital trust. And I'm talking about quantum computing. Quantum computers are still experimental, but when they reach maturity, they could break many of the cryptographic algorithms that secure our digital signatures and blockchain systems today. If that happens, it won't be just a technical issue. It will be a crisis of trust and provenance. Imagine entire networks where the authenticity of contracts, transactions, or even identities could be questioned. This may sound distant, but preparing for it starts now. Across the ecosystem, researchers are already exploring post-quantum cryptography, including blockchain signatures and key management to quantum-resistant alternatives. It's a long-term effort, but it shows that industry is aware of the challenge and is taking the first steps to address it. The lesson here is that trust in the digital age is not static. It depends on our ability to anticipate risks and that don't yet exist, and to adapt before those risks become real. Now let's move from theory to practice. What does resilience look like in smart contract systems? Resilience means designing systems that can fail gracefully, not catastrophically. It means implementing monitoring tools that can detect anomalies in real time, layered security models that isolate failures, and well-defined governance processes for recovery and accountability. It's not only about the code itself, but also about how it interacts with the wider infrastructure, nodes, wallets, APIs, and human operators. In this sense, smart contract security is no longer purely a technical challenge, but it is a multidisciplinary one where developers, auditors, and business leaders must work together to embed resilience at every layer of the stack. In traditional companies, resilience comes from having backups, drills, recovery plans. In blockchain, we need the same mindset, knowing how to act quickly and transparently when something goes wrong. Of course, resilience doesn't happen by chance. It has been, it has to be built freely through processes that and checks that make security part of the system's DNA. So the question becomes, how do we turn resilience into practice? One of the most common and still essential tools is the smart contract audit. An audit is an independent review of a contract's code before it's deployed on chain. So its goal is to identify logical errors, vulnerabilities, or design flaws that could be exploited later. But as many experts often remind us, audits are not a silver bullet. They provide assurance, not immunity. Too often, audits are treated as a checkbox. So something that satisfies investors or users, but doesn't necessarily make a system secure. Real resilience comes when audits are part of an ongoing process, not a one-time event. The idea is to shift from security to inspection to security by design. Meaning that safety considerations are built into the development process from the very beginning. To make this more concrete, many organizations now complement audits with penetration testing that are simulated attacks that test how a system behaves under real-world pressure. So these penetration tests don't look just for bugs in the code, but they help teams understand how different components interact. and where operational weaknesses might emerge. But even that isn't enough on its own. That's why bug bounty programs have become such an important piece of the ecosystem. They open the security process to a wider community of ethical hackers who are rewarded for finding and reporting vulnerabilities before malicious actors can exploit them. This creates a dynamic, self-improving model of defense. Instead of assuming that perfection is possible, it accepts that vulnerabilities will always exist and turns the collective expertise of the community into a proactive layer of protection. We could say that this is the point where transparency becomes a defense mechanism. By allowing more eyes to review and test the system, projects are not only catch more potential flaws, but also build credibility. In Web3, reputation and trust often travel faster than code. A project that demonstrates openness about its security practices tends to gain more confidence from users, partners, and investors. In this sense, making security collaborative is as much as a cultural shift as a technical one. It encourages developers, auditors, and even users to share responsibility for the system's integrity. It reflects a new mindset that protecting a decentralized ecosystem requires a decentralized approach to security. And this continuous community-driven model doesn't just prevent failures. It creates an environment where learning, improvement, and accountability are part of the system itself. And another area that offers valuable lessons, in my opinion, is digital asset custody. Custody solutions, whether institutional or retail, have long faced similar challenges to those we now see in smart contract ecosystems, particularly when it comes to access control, key management, and segregation of duties. These are not new topics, but they remain some of the hardest to get right. A clear example of this came earlier this year with the Bybit breach, where attackers managed to access and withdraw tens of millions of dollars worth of assets. What stood out from this incident is that it wasn't caused by a failure of blockchain technology itself. The blockchain did exactly what it was designed to do. It executed valid transaction. The failure happened at the operational layer. Weaknesses in internal processes, authorization flows, and oversight mechanisms allowed attackers to exploit gaps in human and organization control. In other words, the problem wasn't the code. It was the context in which the code was used. This is a critical reminder for everyone building in Web3. Even the most secure smart contract can be compromised if the surrounding infrastructure and governance are weak. We often talk about cryptography, audits, and formal verification, but none of this matter if a single person can unilaterally approve transactions or if access credentials are poorly managed. For smart contracts, the lesson from custody is clear. Security must extend beyond the contract's logic and into the operational design of the system. That means implementing clear role separation, redundant controls, and continuous verification of who can do what within a protocol or organization. And it also means having incident response procedures in place, because when something goes wrong, speed, coordination, and communication make the difference between a contained issue and a major crisis. And ultimately, technology alone doesn't create trust, but governance does. And governance in this context isn't just about compliance or structure. It's about building predictable and accountable behavior into decentralized systems. That's how we move from security as code to security as culture. All of these examples point to a larger theme. Digital trust is being redefined. In a post-quantum AI-driven world, trust won't come just from removing the intermediaries, but it will come from building systems that are transparent, auditable, and resilient to change. We're moving from a model of blind trust in institution to one of verifiable trust in systems. It's a bit different. But even verifiable systems depend on people, the designers, developers, and communities that maintain them. So digital trust is not just a technological construct, it's a social construct, an ongoing negotiation between what we can automate and what we must still oversee. To conclude, smart contract security is not just about fixing bugs or writing better code. It's about cultivating a mindset of resilience, foresight, and collaboration. If there is one takeaway from all of this speech, it's that security and trust are not endpoints. They are continuous processes that evolve with technology itself. As we build the next generation of decentralized systems, from finance to construction and beyond, our real challenge is not only to make them work, but to make them trustworthy. Thank you very much for your attention. If you have questions about what we've discussed so far from a business perspective, since I'm not a tech guy, or also questions regarding my association, Blockchain Student Association Italy, I'll be very happy to answer.